Okay, so let's start. Thank you, everyone, showing up here. This is the OnTech, the 8th version. I'm so happy to be with you today. We have two nice speaks today, two nice talks. With the first one with Osama. I want to just add one thing before I let him start. I want give very long introductions. So I would like also to thank Get Your Guide for allowing us to use their corporate account to have Zoom without interruptions. And yeah, and that's it. I hope you enjoy it, and stay home, stay safe. Osama, you can start now.
Okay, thank you, Ashraf, for your introduction, and thank you guys for attending this session today. I hope that you all get benefit from everything I'm going to say. And so, okay, I'll be sharing now my screen. Just a second. So, I guess everybody can see my screen now.
Yep.
Okay. So today I'm going to speak about one of the best things I believe, from my opinion, that happened during the past 7 or 8 years, which I see that it has a lot of development and a lot of new things or new stuff that happened to infrastructure, which is the using infrastructure as a code, or deploying infrastructure on the clouds and hardware resources via code and configuration files. So first of all, I would love to introduce myself. I am Osama ElGebaly. I'm a senior system engineer and DevOps engineer. I am around 10 years of experience as a system engineer, and have been here in Germany for 3 years now, 2 years and 8 months, I guess. And mainly I work with Linux operating system and Unix cloud platforms like AWS and GCP. And also have some DevOps approaches like automation, configuration management, release management. I also work as a database administrator, and also applying some ITIL approaches like event management, incident management, problem management, troubleshooting, and so on. So about today's agenda, I will be speaking about the recent challenges that infrastructure faced, and we'll speak about one of the most important types of infrastructure, which is immutable infrastructure, and why using infrastructure as a code and automation of infrastructure provisioning is very important, and different approaches of writing infrastructure code and config files, the tools that are commonly used for infrastructure as a code. And the second part will be about the latest infrastructure as a code approaches, which is like building infrastructure as the same way you build a software code. And we'll speak about our tool today, which is called Pulumi. And at the end, we'll have a small demo with our tool, and we'll leave about like 5 to 10 minutes at the end for Q&A. So first, I would like to say that I will be back around the year 2007, where I started my career as a system engineer. So I used to work for a company where I was responsible for providing infrastructure resources for developers and new projects and clients. So whenever we have a new project or clients, I used to go to places the same way that looks like those that you can see on those pictures. Those are data centers where we have infrastructure and hardware resources are installed. So the process for obtaining a new infrastructure or a new server for any purpose were very mind-blowing and very time-consuming, and also will cost a lot of money, efforts, and so on. So it was very tiring process to provide a new server, and providing like cabling, network, and all the reachability ways, and ensuring everything is in place was a very tiring process for system engineers. A couple of years later, we had the cloud, which was like a big surprise for all of us, where obtaining infrastructure resources became much easier. And since everything in the cloud is all about a few API calls, and thankfully we have management consoles and CLIs, and so obtaining any infrastructure and compute resources on the cloud was very easy and simple. And also you can control your costs since you pay as you use. So during this time, we had some challenges for cloud development. First was having the virtual machines, which is the initial wave of cloud computing, where it offered lift and shift migration strategies and completely flipped the infrastructure planning. And since the virtual machine is the initial term of any server or machine on the cloud. Then we had containers and Kubernetes, where it offered complete improvements over virtual machines. It's also well suited for cloud native approaches, infrastructure abstraction, operating system isolation, and it's also providing a perfect model for highly distributed applications. Serverless. Serverless offers the current ultimate rule for the cloud, providing a stateless mesh of on-demand, infinitely scalable services with options for arbitrary code execution. All you have to do is upload your code and everything will be operated as required. So, speaking about infrastructure as a code, we can say that we're gonna treat infrastructure provisioning and creation the same way we treat our application code. So when you treat your infrastructure like your application code, you can be confident that infrastructure files files will not be lost easily. You have a safe place where you keep your infrastructure configuration files and codes, because with your application code, you will store the files and you have the ability to store it in version control systems. And you will enjoy additional features like finding all the change history that occurred to your infrastructure code files, easy for rollback all the changes, providing also a redundant storage and one source of truth for infrastructure files. And by the movement of infrastructure automation, we had the immutable infrastructure, which is like infrastructure paradigm where servers are never modified after they were deployed. You deploy a server one time, you never modify it, you never do any change. And whenever you require any change for the server, so a new server or virtual machine will replace the existing one using a set of machine images. And to define a machine image, it's like a template, or it's a template for complete virtual machine, including all the necessary files and operating system and configuration files and everything that you require to operate and run your application. So why do we have infrastructure as a code important and necessary? Because I can see it provides a set of features. First, consistency and reliability. And it's because manual infrastructure management will result in discrepancies, no matter how hard you try. But infrastructure as code solves that problem by having the configuration files as a single source of truth. The way you guarantee the same configurations will be deployed over and over without discrepancies. And also you can version control the configuration files, like the source code files. And you also have the full traceability of all the previous changes without applying any guessing games like what happened, who did, and so on. Ease of deployment. Very easy to deploy infrastructure using any of the tools that we're gonna speak about. You can deploy a complete infrastructure and compute resources, virtual machine, network resources, security, storage, databases, and so on, using a simple script. You can do that for every environment, for all your environments, like beginning from the QA, staging, development, sandboxes, and production. So this way you will have all your software development lifecycle more efficient. Automation. Automation always decreases the management overhead, which is required to maintain the complex infrastructure environments. Cost and time saving, where engineers will spend less time performing repetitive manual actions and more on higher value tasks. Another added advantage is that spinning down, you have the feature for spinning down your old infrastructure or the ones that is currently unused and no need for them. All of this will result in decreasing the costs of the cloud resources you are using, since we said you also pay as you use. Auto-scaling resources is one of the biggest and most important features for infrastructure automation, and also it maximizes the benefits of the cloud. Where auto-scaling the process of auto-scaling is based on detecting the unhealthy virtual machines and cloud resources and replace it with more healthier and much better state infrastructure. And with this way, you guarantee the best performance and availability for your service. So speaking about the approaches which is necessary for building infrastructure as a code, we have two different approaches. The first one is the declarative approach, which is like the way of thinking and deciding what type of compute resources and infrastructure resources that is required. From a high level, we plan for our infrastructure resources, detect costs, decide for capacity, and what type of infrastructure resources we use. It's like a full planning process and for the creation of infrastructure. While the other approach is the imperative approach, which is the way how we will implement and deploy and spin up all these infrastructure and have it all in place and as required, with all the guarantee of having the best performance, the best availability, and the best way for running our services. So this part I will speak about two of the most important tools that is being used for the creation of infrastructure as a code, which are AWS CloudFormation and Terraform. Both of the tools have common things, also have different things. So speaking about CloudFormation, it's owned by AWS, and it's the main tool for building for building infrastructure by infrastructure as a code. While Terraform is owned by a company called HashiCorp. The language used for CloudFormation is JSON and YAML, while for Terraform, it's a resource management language called HashiCorp HCL, HashiCorp Configuration Language. AWS CloudFormation is a single cloud platform and only can manage AWS resources, while Terraform can manage resources with all the different cloud vendors. One important thing about building infrastructure using code files is, as a result of building infrastructure, you will have what is called state files, which keeps the history and keeps the changes history of all your infrastructure environments. So those state files for CloudFormation are saved and managed by AWS. So it completely removes the overhead of storing such files. While for Terraform, you have to store it yourself, either in the cloud on any storage resources like S3 buckets, or you can store it also to code repositories like Git, or you can store it locally on your local machine. CloudFormation providing a GUI, a very friendly interface to build resources, while HashiCorp, you only have to use the CLI or the command line interface. One negative thing for CloudFormation, it's only manages the resources that is created by CloudFormation. While with Terraform, you can either manage the resources created by Terraform and or even the resources created by CloudFormation. With CloudFormation, have one good option that is you can rollback will happen automatically when you have any problem or error as a result for building your infrastructure. While Terraform, the rollback should be executed manually. There is no automatic rollback happening. Here are two different samples of code files or config files that is written in both YAML and HTML for CloudFormation and Terraform. So on the left side, we have here an EC2 instance that is built and written in YAML to be created on AWS. As you can see here, there are some set of compute resources like security groups, storage devices are all created. On the right side here, we have also a resource management for the same example, which is building a AWS instance on of type T2 micro. So here we came to the second part of our session today, which is the most recent approaches that happened to building infrastructure as a code, which is called infrastructure as a software. For infrastructure as a software, if we can define the meaning, it's programmatically defining infrastructure using modern programming languages. So knowing programming language like TypeScript, JavaScript, Go, and Python will give you the feature and the ability to use programming SDKs for building cloud infrastructure and compute resources, which means fully codifying our infrastructure right away and use modern programming languages instead of configuration management tools and text editors and so on. So why this is important? Because using and adopting this approach, we can easily leverage the software principles in infrastructure composition, and using programming languages like features like inheritance, abstraction, encapsulation, recursion, looping, and error management and error handling. This also will power up the capabilities and productivity. Also, adding and having more control when it comes to governors of cloud environments, and having our compute resources specified in application or library, which means that we can check and control what code and states changes are happening before we push our code via deployment pipelines. Write testable code, which means that we will test and debug our codes before the beginning of execution, our infrastructure provisioning. Test and debug. We can create coexistence between infrastructure and application code, where deployment of and execution of event-driven applications and infrastructure are all encapsulated in the same source code. You have the feature to have the source code for your software and also the same source code for your infrastructure are all in one place maybe one code repository, maybe one source code. So our tool today that we are going to speak about is called Pulumi. And Pulumi is an open source cloud native tool and platform that is used for building and deploying cloud infrastructure and application in your favorite programming languages. Programming languages like TypeScript, Go, Python, .NET, Java, Python, and so on. It's also a multi-cloud platform. You can use it with any cloud environment, either AWS, Azure, Google Cloud. Also provide the multi-language runtime, supports languages, programming languages, SDKs and libraries, where you can use it, where each of the cloud environment have its own development SDKs. Also, Pulumi provides a cloud development platform, a full platform where you can use to build your infrastructure code, and providing a combination of tools and libraries, runtime and services that deliver consistent development and operational control for cloud native infrastructure. So our slide here have different examples of real programming language, real code written in real and famous programming languages like JavaScript and Python. For example, this code will spin up a new version, a new EC2 instance on AWS. This script will also spin up or create or run a Docker container of Nginx software. And this one will build a full Kubernetes cluster and deploy an Nginx container to the Kubernetes cluster. Now I will apply a very simple demo with our tool, just to get you some familiarity and information about how to use the tool itself. I will create, using Python and Pulumi, I will create an EC2 instance with type T2 macro. We'll create a security group with 2 ingress rules, SSH and HTTP. We'll create, all these resources are created on AWS. We'll create an SSH key pair and install a LAMP stack on the EC2 instance. So I'm going to navigate now to my shell. First, I would, yes, wait, okay. So I will create a new directory for our project. And we'll use our, I have already the platform and everything installed in my machine. You can find all the installation steps on the Pulumi website. I will create, to create a new project, I will write Pulumi new. So I have the choice which type of project I need to use. I have selected an AWS Python project. I will create, provide the project name, description, and so when creating a new project on Pulumi, actually it creates a new stack. So just to differentiate between different stacks or your different environment. So I will keep the same as called dev, and will enter the region I am be using on AWS to create my infrastructure. I will use the EU/West 1. Okay, so here it provides 3 steps which is to create a new virtual environment. You can use this only if you are not installing Python on your local machine. But since I have the Python installed on my local machine, I don't have to run all these 3 steps. So whenever a new project is created, there are a few files are already created, which is the YAML or two configuration YAML files and requirements of the text, which is the libraries that is necessary for Python, and the main Python file that we will have that we will use to write our code. So I have already my code. I have my script already here. I will just show you, and we will go through all the line codes and show you exactly what I am going to do. So at the beginning, I am just importing the 2 main libraries required for AWS. I will define a new SSH key pair. I have this function, aws.ec2.resource name. And with this one, I'm creating a new key pair on AWS and providing my local public key. And later I will be using to SSH into the EC2 machine. I'm defining the size of the EC2 instance. I am declaring or calling for the AMI I'll be using. And since I need the machine, the virtual machine to be with Ubuntu operating system. And I'm defining a security group, a new security group with the outbound rule to open all the traffic and 2 inbound rules for opening the SSH and HTTP ports. And here I'm defining a small shell script to apply some changes for the virtual machine. I will update the operating system, define the password for MySQL, and I will install the Apache in MySQL server and PHP and some other libraries. I will do some privilege and rule changes to some configuration files for Apache and for Apache and PHP. And I will output or create the php.info, which we will be using to find out if PHP is successfully installed. And here I'm defining the creation of my AWS instance, where I'm using aws.ec2.instance procedure. I'm providing some parameters like the name and some and tags and instance type and security group and AMI and the key pair name and the user data, which is the startup script. And at the end, I will output the public IP and public host name for the created EC2 instance. So I will get back to my shell again to execute. I will just need to copy the this file to my project directory. And with one simple command, I will start spinning up my infrastructure and only write Pulumi up. So when writing and executing Pulumi up, it will start to read all the code and configuration file and find out about which resources it is required to be created and my required stack. And it also detected that I need to create some of the resources and giving me the choice to continue. So I will select yes and continue. So starting from here, Pulumi will start some API calls for AWS cloud platform, and will start to create the required resources and providing a state of creating all my resources. So now it already created the key pair and security group, and the creation of the instance is still in process. So now everything should be created, and my desired output is already here, which is the public DNS and the public IP of the virtual machine, and providing the full duration where all these resources were created, which is like less than 1 minute. So I will navigate back to my AWS Management Console, and I'm gonna refresh the view for my EC2 instance. 1 second. So here I have one newly created EC2 instance with all the features, with all the options I have selected. I will copy the public DNS for the machine and we'll paste it to the, 1 second. And I have the Apache welcome page. And also will open the php.info page. So this way I have successfully installed Apache and PHP on my EC2 instance. I will get back again to my shell and do SSH to the public IP. Ubuntu at 3.12.81.12-i/root/id. Yes. So now I have successfully SSH'd into my machine, and I will try to connect to my SQL server using the username and password I have created. Oh, sorry. So here I have my SQL server already installed in my machine. So now I have all my resources successfully created and tested, and everything's fine. I need to roll back the change I did. Sorry, I will first explore the stack. Okay, Pulumi is providing me a feature of exploring the projects and stacks I have been through, I have created, and providing all the history of the project. And providing a GUI view of all the created resources for all the projects. So this is my last project I have created. I can view all the resources and everything was created for this project. Showing some information about the project, the owner and the description for the project, the recent activities that happened and updates happened to the projects, where the recent resource created, the timeline, and the configurations used, and the environments. But also providing a full information about all the resources that were created, key pair, security group, and EC2 instance, and so on. So I'll get back to delete all the resources I have created. With one simple command, I will do Pulumi destroy. So I will get all my resources now deleted. This deletion will happen based on the latest changes occurred to the project. So it will find out and read about the recent cloud resources created, and will start also by calling some API calls to destroy and delete all these cloud resources. So Okay, so just to summarize all the points that I have created during the session, I spoke about what all the cloud development, recent cloud development happened, the need for infrastructure as a code and the meaning of infrastructure as a code, different infrastructure as a code tools, and what are the new approaches, and about our tool and why it makes it different. Sorry. So, questions?
So thank you very much, Osama. So now it's time for questions. If anyone has any question, maybe just raise your hand or something, and we will unmute one by one just to make sure that it's a bit organized. Okay, first one, you can go, Ahmed. Just a moment.
Hey, can you hear me?
Yes.
Yes.
Okay, perfect. So I have a couple of questions. So first question is actually, when you were creating Pulumi, you were saying that I want AWS plus Python. So is it actually a wrapper on top of the AWS, sorry, on the Python SDK provided by AWS, or it's actually something implemented from scratch by Pulumi? Why I'm asking this, because for example, AWS might be providing SDK for Java, SDK for Python, SDK for .NET, let's say. And all these SDKs have different versions. Maybe the Java one is the most up to date with the recent features from AWS, and the Python one, for example, is, for example, a couple of releases behind. So in this case, if you try to use some features available in the Java SDK, in the Python SDK, it's not going to work. So how actually Pulumi handles this? Is it building on top of the SDK itself, or is it using the REST API, for example, directly when communicating or when trying to create resources, for example? So this is the first question. The second question, when you showed this web page for checking the configuration you did for your resources, so how are actually secrets handled? Are they hashed or encrypted or something like this in order to avoid the misuse of these secrets?
Okay. So to answer your first question, all the SDKs and libraries are built on top of Pulumi, okay, and by Pulumi developers and provided by Pulumi. And it's also, but it uses all the API calls that is that is used with AWS. Like, for example, the function that is necessary to used for creating an EC2 instance will use the API calls that AWS recognizes for creating an EC2 instance. So the whole SDKs and libraries are all built by Pulumi and provided by Pulumi, okay? And from time to time, it's updated by Pulumi, okay? Does it answer your question? The first question? Hello? Are you still there, Ahmed?
Yep, it answers, yeah.
Okay.
But,
okay.
Yeah.
And for the second questions, okay. So okay, management of the management of secrets is also can be managed by Pulumi. I'm not sure about this because I haven't used this feature yet, but I'm not sure if there is also an integration between any secret management tools like Vault and so on. Okay, does it answer your question?
Yep, thank you.
Okay. Thank you so much.
Okay, so we have 3 more people asking questions. So I think, Muhammad Shaban, you were next, so you can go.
Okay, thanks, Osama, for the talk. So my question is actually regarding the secrets, like in general, not in Pulumi specific. When you talk about the infrastructure as code, and secrets, like what's the best practice to deal with secrets? Because for instance, in Terraform, when you try to provision like some configuration or some secrets for parameter store or secrets manager, that means that secrets will be visible, right? Or like if you have a remote state or something, that means that secrets will be also stored unless you make them like, I don't know, flag them as secrets. So in general, how do you manage secrets? Do you also treat them as infrastructure as code, or you just provision them manually, or use dummy data and then change them later? Or, like, yeah. So
okay. How this managed as a secret? How secrets managed? For example, for Terraform. So Terraform has its own secret management tool, which is called the HashiCorp Vault, where you can encrypt all your secrets and store it into configuration file into in encrypted form. And with Terraform Vault, you can encrypt and decrypt such secrets and use it. I don't know how to say, like encryption and decryption happens between the Terraform Vault and the Terraform tool itself and configuration files. So yes, you can store your secrets masked and encrypted, and the job of encryption and decryption can be handled by the Terraform Vault tool. For Pulumi, to be honest, I haven't yet used this feature, but as per my knowledge, that also Pulumi has their own secret management tool, but I haven't used yet. So maybe I can go through this and read about it and find an answer for your question for Pulumi.
Okay, I think to keep that time, we can take one more question. I think the next one would be Muha. I will unmute you and then you can go.
Hello guys, thanks Osama for the question, for the representation. I have a couple of questions. The first one, I wanted to ask about the benefits of using Pulumi instead of the usuals like CloudFormation and Terraform. I know that by using Pulumi, you are using the usual programming language instead of some specific DSL language. But why? Why would I do that? What does it provide more? Is it worth it adding the more complexity? The second question, what makes me use Pulumi instead of the direct AWS SDK for Python, for example? Those are my questions. Thank you.
Okay. So to answer your first question, I will get back to, sorry, 1 second. So this slide. Okay, so one good feature for Pulumi is, you know that using any programming language, having a lot of features to use like abstraction, using inheritance, creation of classes, and using all the normal programming language feature, which doesn't exist in using any like text editor or things like YAML. For me, YAML is not actual code. And for many developers, they require to, in addition to learning programming language, they will learn how to use YAML and write configuration files in YAML. So this is additional thing to learn. And actually, I can see that YAML is not a code. It's not actually maintainable. You are also lacking the features like debugging and error handling and stuff like that. And sorry, what was the second question? Hello.
So the second question was, what makes me use Pulumi instead of the direct use of AWS SDK for Python, for example?
Okay. Okay, I can say that. So Pulumi is not only providing a programming language, but it's also providing a full platform to maintain the spinning of infrastructure. You understand the idea first of having the infrastructure automated, creation of the automation of infrastructure creation. You also have the full platform that will maintain and keep the history and will keep the history of changes, keep all your configuration files all saved in one place. From time to time, will provide you the new features and changes that will keep you up to date with all the cloud resources that is newly created and provided. So, yes, I think this is. I hope this answered your question.
Okay. So yeah, apologies to Muhammad Yahya, we will not be able to take your question just to stay within the time limit. And thanks again for Osama. We can go for let's say 3 minutes break or something. And then we go with the next talk by Mahmoud Eleryan at 3:55 or 4 maximum we start. Mahmoud, are you ready?
Yeah, I'm ready. So
I would say
start now or wait 5 minutes.
I think let's start. I don't see a reason.
Okay.
If someone has a reason, they can write it in the chat.
Okay.
Okay, you can start.
Okay. So thanks, Mohammed, for organizing this and for the invitation for the event from the group. Starting by a brief introduction about myself. My name is Mahmoud Eleryan. I have around 14 years of experience and currently mainly in Microsoft technologies. Okay, I'm currently working as an IT consultant or solutions architect. and I'm mainly specialized in the Azure Cloud Platform, Office 365, SharePoint, online on-premises administration and development, and also solution designs of the enterprise applications. In this session of today, I will talk to you about serverless capabilities from Azure platform that you can use it in if you are designing a new solution for your company or for your client as well. Okay, so the trigger, let me just first start video. Why we are speaking about this topic today? Okay, usually when you are writing your software or the software at your company for the client, okay, the next step, or maybe during the design of the solution itself, you will think, okay, where my code will be running. Okay, do I design the application to run on a virtual machine or a container or a cloud app, utilizing the different cloud models from the different providers, either on AWS or on Azure, for example. Okay, so initially, as you know, everyone started with writing his code to run on an infrastructure as a service. If you're speaking about cloud, which mainly a virtual machine, or if we speak previously about on-premises and you are designing a web application, then okay, I write my web application to run on iOS on a web server, for example. Okay, then the cloud came, then we have infrastructure as a service, we have platform as a service, we have container, and all this kind of different options. Okay, in this session today, we are not comparing between the different options, okay, but we are giving you another option that you can consider in the solution design in your day-to-day activities, okay, which is mainly about the serverless. Okay, why do we need, or what would be the benefit if we go with serverless? Okay, but before we say why do we go with serverless, the idea of serverless architecture or serverless solution design is mainly about to design a solution which you don't need to worry about which infrastructure it will be running this application. Will it be Windows? Will it be Linux? And I don't need to worry about maintaining all the infrastructure behind it. I don't need, for example, if it's a virtual machine, I don't need to worry about a user admin password. I don't need to worry about patching the virtual machine, group policies applied or not, security hardening, all this kind of stuff. I don't need to worry about disk space. I don't need to worry about backup and restore, all this kind of stuff. In addition to that, if I would be relying on an infrastructure, okay, I need to worry about the sizing of the infrastructure. I need to worry about the scalability of the infrastructure behind which will be hosting the application to respond to different events. Could be increase in demand on the solution or could be scaling out. So instead of sitting idle, and if we speak about cloud, I pay for each computing resource, then I scale it down, for example. Okay, this kind of things. If we go for the serverless architecture, we don't need to worry about all this kind of administrative activities. If we speak in our session today, we speak mainly about what could be the different alternatives available in Azure platform that can help you as a solution architect on designing the solution. They have something called Azure Functions. We have Azure Logic Apps, Service Bus, and Event Grid. These are not the only options which you can use to design the solution using serverless architecture. These are just some examples. Okay, for example, we still have Azure Automation, we still have Cosmos DB, and all this kind of stuff. You can rely on it on designing the solution in a following serverless architecture. For our session today, just for the sake of time, we will focus on the first two examples, Azure Functions and Azure Logic Apps. Give a brief introduction about them and what are the pricing model which you can consider in the designing your application. Okay, and for the rest, I think you can do your own research about it, and if you have any questions about it after the session, I would be happy to answer your questions. Azure Functions, as we explained, it's serverless compute service from Azure, where you implement your solution based on this Azure function, which can run on using any development language, not any. Currently, it supports C#, F#, Java, PowerShell, or JavaScript. Okay, so you can write your code in any of these programming languages, publish it to Azure Function, then you can integrate it into your application. Azure Function, you provision it without the need to provision infrastructure. I will show you later in a demo for the session today how you can create an Azure function. Azure function, it's being provided from Azure in 2 different pricing models. The first one is consumption plan, which is simply pay as you go. Okay, if you don't use it, you don't pay for it. If you call the Azure function or you execute an event for the Azure function, then you will be just charged based on number of the events which you are executing. In addition to that, if you have an Azure subscription for Azure function, I believe you have around 1 million execution for free. You don't need to pay for it. More than that, you will be charged for the Azure function. Okay, and I will show you some examples here how you can calculate the costs. If you have some numbers, how you can forecast the cost for the Azure function. Okay, this consumption plan could be tricky for some organizations or some clients. Okay, they can say, okay, I don't know how the application, how many clients will be, how many transactions will be executed. I cannot say, for example, I cannot prepare a budget for the financial department or for the management. I can say I need $500, for example, for this application to run on Azure, or 1,000, for example, or less than 100. Okay, so there could be a lot of questions coming from this, and sometimes it's tricky to plan based on this consumption plan. Okay, however, it could be cheaper, you know, if your application is not does not have a high load, and most of the time it will be idle. So this could be a safer plan for you. Some other clients or organization plan, no, okay, I need to have some predefined budget, which I plan based on it. This is why Microsoft offered this app service plan, where you select the deployment size, which is simply in the back end, for sure, for the infrastructure, you select how many amount of memory will be allocated to this Azure function app, which you are creating, how many number of virtual cores will be associated, for example. And based on this, they tell you, okay, you will have to pay $100, $200, or less than $100 per month, for example, in order to run the Azure function app. But the point here is, if your function app, okay, will be under heavy load, okay, and if this app service in the background does not is not able to serve the high workload, then you could have performance issues, okay, because you selected a specific size. However, the number of transactions is more than or require resources more than the allocated resources. Okay. The benefit of going with the consumption plan, that you don't need to worry about the sizing, you don't need to worry about the scaling of the application. Microsoft already have some agents installed and on the hosting environment running this consumption plan, and it automatically detects, okay, now the number of transactions is being increased, okay, and it automatically provision additional hosting instances to respond to this increase of workload. And after this workload is being decreased, these kind of hosting instances are being removed from the hosting, and it will be scaled down, that you don't need to pay for all of these infrastructure. A sample solution architecture where you can utilize Azure function for the implementation of your web application. If we look to this solution, let's say this is an online e-commerce portal, for example, where we will have a web application. The user will go to the web application. He can select the products and then select order, for example. Then the order functionality coming from the single web application will send an HTTP request, okay, to the function app, which could be writing this data into a Cosmos DB, which will be picked up later by another application to handle the order processing, for example. Okay. Previously, for developers previously from the old days, if you will be designing this web application, it will be the web application which will include the web interface and also will include the logic for writing the data to the Cosmos DB. Azure Portal provide additional services which you can use to secure the function, which is called API management. Okay, which you can integrate it with Azure Active Directory to handle the authentication part. That you can configure that the Azure function is not accessible as anonymous over the internet, but it can be accessed only for authentication accounts. Another option, based on the business requirements, you can export the function app as anonymous, okay? Or there is another authentication option where you can, it gives you a unique ID, like usually you say secret or code, something like this, where you can only accept the requests which has this code included into the request. Okay, and I will show you later how to configure these different options. Function app provisioning can be done either from the web interface, from the portal, from Azure, or can be done using Terraform as showed by Osama in the previous slide, or can be done using PowerShell, for example. And I will show you this in the demo. The second example, which we picked up for the session for today, Azure Logic Apps. Okay, the difference between Azure Logic Apps, Logic Apps similarly provide a serverless compute service from Azure, and it's used for designing a logic which is mainly based on a workflow. Okay, and the difference between Azure Logic Apps and Azure Function, that Azure Function mainly about someone coming from the implementation from the logic in a coding format. Okay, however, Azure Logic Apps, it gives you a graphical user interface where you can design your logic in an interface, okay, not by writing the code. Similarly to Azure Function, it does not need to worry about provisioning and infrastructure, as this is something will be handled by Microsoft. Azure Logic Apps, just a concept. If you will be working with Logic Apps, it consists of three main components. The trigger, what will be the trigger which will be triggering the Logic app, and at which event? Okay, will it be in case it receives an HTTP request, for example? Or it can be configured if you have another service, let's say from Office 365, SharePoint, or Dynamics. You can say when a document is being uploaded to a document library. This is if you have a knowledge about SharePoint, or if you can say if there is a new sales opportunity added into Microsoft Dynamics, which is a CRM, or you can say when, I don't know, it can be run on a scheduled basis. Okay, and in the demo later you will see which kind of triggers you can configure the Logic app to respond to. Okay, also the different steps of the Logic app which will be used to execute the logic is called actions. Okay, you can say, okay, if there is an HTTP, if there is a new sales opportunity coming from a CRM, you can trigger another function. Okay, so you can use Logic app also to integrate with different systems. Okay, so you can receive the request to the Logic app, you process some logic, and then you trigger another Azure function which can be integrated with a Cosmos DB, for example. Okay, connections is a list of connectors which will be available in the Logic app that you can use it, which give you the ability to integrate with external systems. Okay, for example, if I need to write data to SQL database or Cosmos DB. Okay, I'm not sure if these. Okay, I believe it are questions, or suppose I don't see some. I see some notifications. Yeah. Okay, so this is for the previous session. That's fine. So the connections are like the interfaces to integrate with the other services. Okay, it could be an Azure service, it could be an external system, it could be another cloud service, for example. Okay, so based on the installed connectors or the available connectors in Azure Logic app, you can execute some sort of actions. Similarly to the Azure function, and here these are just some numbers. The Logic apps provide you with around more than 200 connectors. It has built-on connectors, and these are sample connectors. It could be an API connector, it could be on-premises connector. Okay, and this would ask a question here: are we speaking only to use Azure function or Logic apps only on the cloud? No, there are different approaches which you can extend the Logic app or the Azure function to connect to on-premises solutions, to come in on hybrid implementation, for example. There is a specific gateway which you can install it, which will expose the on-premises solutions that you can integrate it into the Logic app, for example. There are some enterprise connectors to integrate with some enterprise applications like SAP, for example. Similar to the Azure function, Azure Logic apps is being provided into consumption models. The first pricing models. The first one is the consumption plan, where you similarly you pay as you go, and the fixed price one, where you pay in a fixed price per month. and as I explained the difference when to use what, this is based on I would say could be solution requirements, could be client preferences, for example. And this is here a sample application design, okay, which you can utilize logic apps for it. For example, you can have here the client application, which will be handling some logic, and part of the logic being implemented using logic apps, which could be writing data into service bus for queuing, for example, or handling the events. And you have another logic app which is responding. So the first logic app here is writing the data to the queue, and the queue is writing data to the event grid. And you have another logic app which is responding to the event in case there is a new event written to the event grid, for example. Okay, and then the logic app could be processing another logic, which would be writing the data to a service, could be something from Microsoft, could be something from Amazon, could be something like Salesforce, for example, or executing some logic in some of Azure services, for example. Okay, so this is sample solution design. Sorry, there's a spelling mistake here, sample. Okay. Then we move for the demo part to show you how you can create these applications. Okay. For you, if you didn't work with Azure from before, in order to access the different services from Azure, you go to the link portal.azure.com. Okay, and in order to start benefiting from these services from Azure, you should have Azure subscription. Okay, it's different from client to another. For some clients, they have enterprise agreement with Microsoft. Some clients pay as you go. You just go to the internet, subscribe, enter your credit card, then you have your Azure subscription available, and you can start using on it. You can set some spending limit that you are not being charged for too much amount of money, so that you can set some spending limits. Okay, just for this, but for you, if you would like to try to play with the different services from Azure, Microsoft is offering free trial subscription, which give you around 170 euro, valid for 1 month, that you can start using these services. In addition to that, it will keep some services for additional 12 months that you can still using it for free. So this is just if you would like to learn more about these things. And this is what I set up for the session for today as a free trial subscription. Let's start with an Azure function. How to create an Azure function? You create a resource. Okay, this is in case you create it from the user interface. Okay, however, there is another option. It's called PowerShell console here for Azure, which give you a PowerShell interface from the web interface where you can write your own commands. And there is enough documentation on the internet how to create the different Azure resources using PowerShell commands here. So it's now connected. You can switch here between PowerShell and Bash based on your preference. For example, it will take just a few seconds to load fully, and you can write your own PowerShell command here, and it will provision the resource. Okay. For the sake of the demo today, we will rely on the user interface. So let's say I write a function app. I create a function app, create. It will ask for some information from you, which subscription, we use this one, and resource group, this is something like a container. If you worked with Azure from before, for each resource to be created, there should be a logical container, which is called an Azure resource group, that you have to select it. And here you give it here a name, Azure function demo 900, for example. Okay, and this name should be globally unique because it's part of the global DNS Azure websites.net. And here you can specify where to publish it. Do you like to publish it just you publish your code, or you can publish it to be running on a Docker container? Okay, and also what should be the runtime stack for the Azure function? Will be you writing a .NET code, in this case .NET Core, for example, or you will be writing PowerShell, Java, Python based on your preference. Okay, in our demo today we'll use this one, and here you select where the Azure function should be created, in which data center from Azure. Okay, and these are the different regions, the same concept as AWS. For our demo we use Central US. Important information here, this is general for Azure, not only for Azure function. Try to provision the different services which communicate to each other in the same region. Okay, this reduces the latency between the different solution components. And in this step here, you select here which should be the operating system. Is it Windows or Linux? Okay, for you, it should not make a difference. Okay, either it's Linux or Windows. If you are writing .NET Core, for example, because .NET Core can be now hosted on Linux and also can be hosted on Windows. Okay, but it shouldn't make a difference for you. And here the pricing model, if it could be consumption or premium or app service plan. Consumption and premium, based pay as you go, and app service plan, it's fixed storage per month. Okay, it could be another question if I select consumption plan in the beginning, but then later I find that the number of requests is too high. Can you switch to app service plan? This can be done. The other way around, if you provision an Azure function based on app service plan and you find that the server utilization is almost 20 or 30%, then it doesn't make sense that you pay for all of it. You can switch to consumption plan. Here you specify additional monitoring capabilities, something called application insights, which give you more monitoring capabilities for Azure function, but this is not required for now. We can say no, and we click create. It just review the settings. In case everything is valid, you will not get an error message. In case there is an error, it will give you a warning here. Then click create. Okay. For the sake of demo, we don't need to wait until it's being created. I have already one created here. Function app, and this one, it was already created before the session. Okay. And here, this is the user interface to manage the different configuration of the Azure function. And this is a sample one, which is called get full name. Okay. You can, how to write the code for an Azure function. Azure function can be implemented from the user interface. You can write the code from the browser. Okay. However, if you have integration with source code repository, or you prefer to work with Visual Studio, still this can be done with Visual Studio. There is a specific extension which can be installed, and here you can find here, if I click new project and I search for function, here Azure Functions. Once you have this add-in installed for Visual Studio, you will have this option already available here. Okay, and this is a sample function. It's called get full name. Just for the demo, it will expect a query string called name, and if you provide this one, it will return you hello and sorry. It will give you just this message, just for the sake of demo. However, you can implement your own advanced business logic in the solution as per the solution requirements. Once you are done, just right click and publish. Okay, and from here, after you create how to get the publish profile, here this is the option to get the publish profile for the Azure function. You import it from Visual Studio, or even there is an integration between, if you have, you can just log and select existing, create profile. It will ask you for the account from Azure. You can just specify it and it will take you through the steps. Select the Azure subscription, select the resource group, select the Azure function, click publish. Then let's just try to make small changes here. And user, and then it will write the name, and then let's just publish. Yeah, it will take just a few seconds to be published successfully. Okay, publish succeed. If I go now to the user interface and I refresh here, so this is the name of the function app, and the function app can contain one or more different functions. For the demo, we just created this one. And from here, you can try to test it. and let's say Ahmed, for example, and here you specify the trigger method, if it will be get or post, and the same way you can define this in your code. Okay, and then let's try to run it. Hello, you see here, hello user Ahmed, as we already updated the source code. Okay, and the message coming from the source code as well. Okay, this is just to test if it's running successfully or not. Azure Function provide more features. I think for the sake of time, we will not be able to go through it. But for example, you can configure the authentication for it here. No, I think it's from platform features. Yeah. Authentication and authorization, where you can say it's not anonymous. You can say everyone should be authenticated from Azure Active Directory in case you are using Azure Active Directory, or everyone should be authenticated using a Microsoft account, Facebook, Google, Twitter, or something like this. In this case, if we say Azure Active Directory, if you have experience working with Azure Active Directory, it will create something called Azure AD app and all this kind of stuff, which means if you once you click save or OK, for anyone to be able to use this Azure function should have a valid access token in order to be used. Okay. However, you still can keep it anonymous, and you can configure the course settings that it accepts codes coming from a specific URL. Okay. There are a lot of features coming from Function app, but we will not be able to go through it. Okay. So this was just for the demo for today. The other demo which I wanted to show to you today, the logic apps, how to create it the same way. You can create it from the user interface like this, and you click add. So the same way you select subscription, resource group, and you say here easy logic session. And you select here if it should be just deployed to a region or integrated service environment. Integrated service environment in case you have it integrated with the on-premises infrastructure. Okay. For the sake of demo, use this one, West Europe. And if you need to have log analytics for it or not required for the demo. And we click create. It will just take a few seconds to be created. Go to resource. Then the function app is ready to be used by you. Okay, this is here just a quick introduction about logic apps and how you can use it, and then you need to specify here, for example, what would be the trigger of the logic app. For example, if it could be listening to a service bus in case you have a queue, then you can say when there is a new item added to the queue, then trigger the logic app, or when there is an HTTP request is received, trigger the logic app, and things like this. Okay, let's take when there is an HTTP trigger received. Okay, here you can specify what would be expected in the body of the request. Okay, the URL will be generated once you click save, and this will be here the URL of the logic app. Okay, so that you can trigger it from any other client application, for example, or if you would like to test it using Postman. Then you define the next step. Okay, I received the HTTP request. What should be the next step? Maybe I write the data into SQL Server, for example. Okay, or I pass this information to another Azure function, for example. Azure function. And you see here, because there is a native integration between the Azure services, you have this Azure session function which we created. And this is the name of the function. Okay, you can specify here the parameters coming from this HTTP trigger. This is just as an example. Another action could be calling another HTTP API or service, for example. Okay, so this was just a quick demo about Azure function and Azure logic app. If you will start using it, you will find that there are more and more points that you need to consider in your solution design. For example, for Azure logic app, if you would rely on consumption plan, as this is shared infrastructure for between all the clients, they limit the execution time to 10 minutes, which means you cannot write a code which takes more than 10 minutes for a single execution. Okay, if you think you would write a function which could be a scheduled task, which you'll be doing a daily maintenance activity or something like this, you can you will have to switch from a consumption plan to app service plan, for example. As you more and more start using these services, you will have to read about the constraints and the best practice to design your solution based on any of these services. So this was just a quick demo for today.
Mahmoud, sorry to interrupt you. Are you almost done? Just to have some time for questions?
Yeah, actually, I'm done. The next item in my agenda is the questions and answers. So if someone have any questions, would be happy to answer it. Yeah.
Yes, thank you a lot. Yeah, just like the last session, if you have any questions, please raise your hands. Okay, we start with Moody.
Hello, thank you for sharing this awesome session, and the demo was really helpful for me. I have actually a question regarding function.
Yeah.
So actually you talked about the pricing plan and switching between them. If I can start, for example, with the fixed resources, and then I could, and please correct me if I'm wrong, of course, I could actually switch to be a premium one. So it will have the option for scalability to scale up or scale down. This could be done after I create my function, or I should recreate it from scratch with the option of premium.
No, you can change it later if required.
However, it's running already. It's in production, right?
Theoretically, yes. Okay.
Theoretically, yes. Okay.
Theoretically, yes. But I didn't test. I didn't have something running, and I switched it during the working days. Usually, just to be on safe side, Microsoft say there should be no interruption. Okay, but I would prefer to execute such kind of activity maybe after working hours or maybe in the weekend, for example. But it's just few seconds activity. I can show it to you here. For example, this one. Function app. Yeah, this one here. You will find here, this is the assigned pricing tier for your application. Okay, you can create, you need first, in order to switch to an app service plan, you will need to create an app service plan, select the size of the app service plan based on the available budget and also based on the technical requirements, then you can switch between it. Yeah. Okay.
Do we have some kind of schedule this switch? So for example, in case of seasonality, if I'm working as e-commerce, for example, and I wanted to switch to premium in the season of Black Friday. So this could be done. So I could have create something like a cron job inside the Azure. So in this time I need to switch to premium and switch it back, or this could need to be done manually.
No, there are a lot of PowerShell commands which you can utilize it. Okay. And
okay, I got it.
Even you can implement this as a logic app, for example. Okay, which can or an automation account. There is another service from Azure which can schedule this this as a scheduled job on daily or weekly or based on some dates to scale up or down the different services from Azure. Yeah.
Okay, cool. Thank you. I just finished. Thank you for answer. I have another question, but I could do it after meetup to have some space to our colleagues. Thank you.
Yeah, my pleasure always. Well, thank you. Okay. Any other questions?
I think we have another question from Muhammad Ridwan.
Yeah, Mahmoud, thank you very much for your presentation. It's really nice.
My pleasure. Yeah.
Thank you. My question is, is this function app has a warm startup, like for first event coming, you need like some seconds when this container comes up?
Yeah, this is something you need to consider in your pricing Azure function plans, because you have this consumption plan and you have premium and app service plan. Okay, if you have this app service plan, you can configure that you don't need to wait for a few seconds for the first request. Okay, it's always on. They call it always on. Okay, and you see here, I think hopefully this is the right article. So for the consumption plan, you could face this kind of warm-up delay for the first request, but for the premium and app service plan, you have for app service plan, you can configure this always on. So it's always on. You don't need to have this delay. The same for premium, but for consumption plan, I believe you could face this cold startup. Yeah. Does this answer your question?
Yeah, this answers my question. And second question is, can you configure memory for your function?
If you go with the consumption plan, you don't have a control on this. Okay. If you go with the app service plan, it's like your own dedicated instance, and you control the size of the instance, number of virtual CPUs or number of memory. So you have a full control on this. But for sure, as more you increase, as more you pay.
Okay. I don't see any other raised hands. So okay, Moody again.
I'm really sorry, but if we have sometimes, I can quickly ask one question, last question, regarding scalability, scale up and scale down. So you said if we have consumption plan, so I could, the automatic, I have this option for scale up and scale down.
You don't have a control on this. This is automatically done by Microsoft hosting infrastructure.
Exactly. Do you know if they actually scale by horizontal or vertical, or something like what I mean? It's adding more resources in the current host, or adding more hosts beside the original hosts that I have. Do you know this idea?
As per my knowledge, they increase the scale horizontally, not vertically. So they just provision additional hosting instances. Yes.
Okay. And it will be cloned by the first one, the original one.
Yes, exactly. Yes, the source code or the DLLs which you already uploaded will take a copy and provision additional hosting instances. Yes.
Okay.
But there are some cases, okay, which you would have a limit on the scalability, okay. But I say some cases based on the solution design. I faced this limitation in a project which we had Azure function integrated with an event hub, for example, and it's not from Azure function. It's about the overall solution design. The event hub, in event hub, there's something called the partitions, okay, and if you configure the Azure function to listen to an event hub, it's always one hosting instance that can listen to a partition, which means that the Azure function app cannot be scaled out more than the number of partitions. Okay, the workaround for this, you increase the number of partitions that you give the Azure function the space to scale more and more.
I got you. Thank you.
Okay, but if you speak about a general Azure function which is exposed as an HTTP endpoint, it can be scaled without, let's say, without limits, okay, and as per the number of requests is being increased.
And in this case of no limitation of a scale up, do we have some alarm? Or for example, I could set up so if it reach number of hosts and I have a lot of loads, I could just scale it down manually, or I don't have this kind of alarm?
Well, again, if you use the consumption plan, you don't have a control on the scalability.
Okay, I got that.
But if you use the app service plan, this is something you can implement. For example, app service plan, it's in the background. It's like you have a virtual machine with a specific configuration, which will be used to host all the Azure functions part of it. Okay, what you can do, you can monitor the consumption of the CPU, for example. Okay, if I find that the CPU consumption of this app service plan is always running for, less than 40% for 4 hours, then I can scale down this app service plan, for example, okay? Or if I find it's running more than 80% for more than 15 minutes, for example, then I scale it up or out as per your preference. So in summary, the consumption plan and the premium, you don't have a control about scalability. It's automatically scaled based on the demand. App service plan, you have a full control about the scalability of the app service plan.
Thank you. Awesome.
Yeah. Great. And here in this page, this Azure price calculator, if you need to know how much could it cost for me if I rely on the consumption plan, this is called Azure price calculator. You can go and specify which service in which region it will run, okay? And per month or per hour. I think there should be here. If you select here, for let's say I would like to have an estimate for an Azure function, for example, Azure function, and I go here. This is for the Azure function. Which kind of memory size you would like to have, okay, and which tier, and the execution time in millisecond. Okay, let's say it will take 3 seconds, for example, which is 3,000, and the execution per month 2,000. Okay, 2,000 execution per month, then still within the free quota for the Azure subscription. You don't need to pay for something like this. But if we make it million, 1, 2, 3 additional, then you will pay for it around $5 per month for just hosting this Azure function as a consumption plan.
Okay, I think that's all to stay within the time of the event. Thank you, Osama. Thank you, Mahmoud, and thank you everyone who attended. We are looking forward to your feedback. You can send us on Meetup or on our Facebook page. Ashraf also posted a link to our call for speakers. If you would like to speak in our next meetup, please do so. You can visit this link and add your talk, or you can again send us messages on Meetup or the Facebook page. So thank you everyone and enjoy the rest of the day. Bye.
Thank you all. Bye-bye.